Okay, so this support workshop is focusing on Helm, what Helm is, why you would use it, how it integrates with Octopus, and some of the common kind of support questions that we see regarding Helm, and how we can work through those or debug them. So the first question that I think we need to answer is what is Helm? Why would anyone use it? What's its purpose? And Helm, it's probably easier to think of Helm as the package manager for Kubernetes. So here is Bitnami. It's kind of a third-party Helm repository, and or repo, I should say. And it supplies a whole bunch of these open source tools here. So some of them are going to be standalone and quite simple, like MySQL, for example, would just be a standalone database. But things like, WordPress or, Kibana, these types of services tend to be a combination of multiple different packages. And what Helm does is give you a simplified way of deploying and managing what can be quite complex application stacks and all their interdependencies. So there are quite a few different repositories out there. So we've seen we've seen Bitnami, but there's also this one. So this is the feed of the standard open source Helm. Actually, I should probably Google that. Helm.
Good morning.
Hi. Sorry, I just kicked off, but you'll be able to catch the recording
Thanks.
for the start of there.
Yeah, I appreciate it.
Yeah, so there is a standard kind of the default Helm chart repository. Which is this one here. And this again has a whole bunch of open source applications in it. And this is usually the default that most people use when they're first starting with Helm. So actually this word charts here is interesting. That's how Helm refers to the packages, I guess, that it deploys. They're all bundled up into what's called a chart. And the chart is what you deploy onto your Kubernetes cluster. Helm is also a command line tool. So that's this one here. So that's your, when you're running Helm on the CLI to download or deploy the charts. It's the CLI tool from this that's built out of this source code here that you're actually using. In Octopus, though, these Helm concepts have slightly different meanings. So the repositories here that offer all these different applications or all these different charts, they're exposed as external feeds in Octopus. And we treat individual charts basically as packages that are consumed by those feeds or exposed by those feeds. And lastly, in Octopus, Helm is also a step that we can use to deploy the charts. So these feeds here are backed by basically just plain HTTP websites. So if we look at the actual like the data of a feed, let me just open that one. So it's these index.yaml files. Actually, there's probably a better example. So this is the example of the index.yaml file from the Bitnami feed. And as you can see, it's just plain YAML. It lists the feeds as individual items under these entries. And the downloads are just again, HTTP links. So there's not generally a lot of work that has to go into consuming these feeds. It's just a matter of parsing this index file and reading out the charts here, and then getting the versions and the downloads from these values here. And so that's what Octopus does in the background. When you define an external feed to be a Helm chart, it will go off, it will read this file, parse it basically as a package feed, and display these charts here as packages with their versions. And these versions here are semver, so that fits quite nicely with the way Octopus works. So if we go back into here, we go into external feeds. You can see I've set up the two of these chart repositories as feeds. That was the kind of that standard open source one, and that is Bitnami there. So one of the support questions that has come up, and it's based on the fact that we changed how some of these URLs were parsed, was what is the actual URL here? So you can see here, this, I don't think this will actually open anything if I open it directly. Right, it's just going to come up with access denied. So what Octopus actually does is assumes that the end of these URLs is always index.yaml. So if you paste in this feed URL, what Octopus will actually try and read is that URL with index.yaml on the end, and that's the same for this one, this standard one here as well. It'll go off and try and read that /index.yaml. So there were some issues with the way we parsed these URLs in the past, some inconsistencies with the way that whether this suffix was on it or not. So one of the support tools, or one of the debugging techniques you can use, is just always paste in the full path to the index.yaml. And that will work across all versions of Octopus, regardless of whether they've had this parsing fixed or not. That's a quick debugging technique to get people up and running. One of the other questions that is starting to come up is the issue of, or the possibility of using Docker feeds as Helm registries. And so that's only supported for Helm 3, I believe. I don't think that's supported in Helm 2, and even in Helm 3 it's currently experimental. They haven't quite sorted out all the issues here. Some of this terminology is a little bit confusing though, like OCI. What does OCI mean? So to explain this, I think we have to go back a few steps and understand what some of these terms mean. So OCI refers to the Open Containers Initiative. Basically what happened here was that Docker started to become popular and started to have companies outside of Docker itself kind of contributing to this space with tools and platforms and support. And so the Open Container Initiative was formed to give those third-party people standards that they could rely on and they could contribute to. Mostly what it means in the term of when people talk about OCI registries, what this means is that Docker kind of gifted its the formats or the APIs that it was developing for things like registries to this Open Container Initiative group, and then the specs that came out of this this group then became what's referred to as OCI based registries. And really that's just a complicated way of saying if you have a Docker registry, you really have an OCI registry. They're basically interchangeable. I think on a technical level, the OCI specs are slightly more specific, so that maybe they can be considered a subset of Docker or the specifications Docker itself was using. But in generally speaking, you can use these terms OCI registries or Docker registries interchangeably. They refer to the same thing, and they more or less implement the same technologies and APIs. So yeah, when Helm says it has support for OCI package distribution, all it's really saying is that it has support for putting charts into Docker registries. So we don't support this today. We only support that Helm feed where you have that index.yaml. We probably will support this once it becomes not experimental. But that is going to be a question that starts coming up more, I think, because people like Azure and I think even AWS now are kind of standardizing on using their Docker registries as a way of distributing Helm charts. I don't think we'll see these cloud companies build a specialized Helm repository service. They'll just kind of bypass that step and go straight to leveraging the infrastructure they have today for Docker images. So the other thing that's kind of unique to Octopus is that we allow you to not use an external feed at all and actually just put the charts straight into the built-in feed. So if we have a look at what a chart is, so what I'm going to do here is use the Helm CLI to pull down the Nginx ingress chart. It doesn't really matter what this is. We won't dive into the specifics, but I just want to show you what that looks like, or what a chart actually is. So that's what that command downloaded, this tgz file. And if we look in here, you can see that these are the individual files that make up a Helm chart. And so these are the files that the Helm command line tool will read and process as it deploys the application. And so what we've said for Octopus is that you don't need an external Helm feed. It's just, I mean, setting up a Helm feed, it's not hard, but it's just more work that you have to do. And so we give people the option to not do that and just upload these straight to the built-in feed. So the only catch with using the built-in feed is that the format of the file changes slightly from what the default is that Helm uses. You'll notice here it's a dash and then the version number. And if I was to upload that to Octopus, it's going to think everything up to the first dot is the package ID, and then everything after the first dot is the version, which isn't what we want. That -1 is not part of the package ID, but that's just how it will be processed by Octopus. So the simple way around that is to rename the file to this, replace the dash with a dot, and then when you upload it, you get this correct formatting here. There is a bug actually with the current release of Octopus. What you'll notice in these files is that this directory here, Helm kind of has the standard that this directory here will always match what they consider to be the package ID. And if you upload it to Octopus with that incorrect file name, that no longer matches and the deployment breaks. We've actually solved that issue, so that fix will be coming. But if people do use the built-in feed and have uploaded their Helm package with that incorrect file format, they may break. There'll be a file, like an error saying a path can't be found or something like that. So going into the step itself, so you can see it follows a fairly standard pattern of selecting the chart from the package feed. So here I've selected that same Nginx ingress package that I downloaded from the CLI. And then we have, So this is the name of the deployment. So essentially this is saying, this assigns a name basically to the configuration maintained in Kubernetes that represents the this particular deployment of the chart. And that will usually affect some of the names of the resources themselves that get deployed. Namespace here just gives you the option to override the location on the Kubernetes chart where it gets, where the resources get placed. And then things like additional arguments. If you do have any specialized arguments that you wanted to pass to Helm for whatever reason, they can go there.
Hey, Matt, really quickly.
Yep.
You said the OCI support was added in Helm v3. Octopus
Yeah.
supports Helm v3, right? So could you turn on that experimental feature here in this additional arguments?
No, so that setting, this is actually an environment variable, not an argument that gets passed. Yeah. Well,
I see, cool.
I mean, technically what you, so what you could do if you really, really wanted it was just run a like a kubectl script step.
Mm-hmm.
So if we do, something like this, so you go in here and say env, whatever that setting was, that equals, yeah, what was it, 1. And then you go ahead and call Helm upgrade. And probably actually what you do here is, I don't actually have a Docker feed, but you'd reference the Docker feed as an external package, and then not extract. Actually, I'll probably just, yeah, let's actually do this. I think it might come up. Docker. Right, so you set that environment variable there. You would call Helm, and then what you would do is reference a package, set it to not be acquired because you don't really need it. That's one that's going to work, Ubuntu, I think. And then from here, you would just use that package name as part of the command, like the Helm upgrade. I don't know off the top of my head, but you know, it's course.action.packages Ubuntu, I think it's called image. Yeah, so that's one way you could get around it, just calling Helm directly, setting that environment variable for yourself, and using the additional package references as a way of selecting packages as part of the deployment process.
Yeah, cool. Easy enough. Thanks for that.
Yeah, it shouldn't be too hard. And I think given the fact that we have all the pieces in place, we will support it once it's no longer experimental.
Yep.
So on the question of Helm versions, you can see here one of the options in the Helm step is selecting the version of the tool that you're trying to use. So Helm 2 is the, obviously it's the older one. It's the one that became popular, but it had some security issues around the way it worked. It relied on a service in the Kubernetes cluster called Tiller. And that service there was kind of a super deployer. If you had access to deploy to Tiller, it was very hard to use security rules to restrict what you could actually do. And so one of the redesigns they did in v3 was to remove the need for Tiller. Everything is processed client side, and then the resulting Kubernetes objects are created on the server with no special server side resources or services needed. This is important though, because you do need to have the correct version of Helm available either on the Octopus server or the worker that's being used. And so in this case, it defaults to version 3. I'm on Octopus Cloud at the moment. and you'll see I tried to do a deployment, and it's come up with this error saying, okay, well actually there's a couple of different issues here. This one here is me running on a one of the new Linux workers, and that Linux worker doesn't have Helm at all, so I just couldn't run it at all. But this was my first attempt running on one of the Windows dynamic workers, and it only has Helm version 2 installed, not Helm version 3. So this version mismatch here resulted in the error. So there's a few different ways around this particular problem. So what you'll notice here is if I go to worker pools, I have the two different types of worker pools, Windows and Linux. For my step, I have selected the Linux worker pool. And what the easiest way around this is actually just to use these container images here. So this container image has Helm v3 on it. And so I can just run this and that should work. If I was running on Windows, what I would, the other option that I also have is to upload a binary to the built-in library that has Helm in it. So if we look at the Helm releases page, you get all these downloads. So I would want version 3. So I'd grab this one here, the Windows one. That gives you a file called this. So I've actually just saved that, stripped out some of the bits on the end. So we just have helm.3.3.0. Again, that's just to allow the package to be parsed by Octopus when it's uploaded. So that's this package here, Helm and 3.3.0. You'll notice inside these packages, there's this nested directory, Windows AMD64, and then we have helm.exe. So what I would do in here is use one of the settings down the bottom that lets me reference that package from the built-in feed and then define the location of that helm.exe. So I would do custom package. I grab my Helm here, and then I would say the executable location is that. I might just save that and just change this to Windows. We can see that running. The deployment may actually fail still. The cluster I have is kind of in this weird state where I've just been testing stuff, so I'm not even sure the deployment will work, but we'll see that at the very least it can call helm.exe, and there's no issues there with the versions of the executable that we're trying to use. A second. So you can see that it's downloaded the executable that includes, the package that includes the Helm executable, and that'll be put on the worker, and then that will reference the executable from that. Yeah, so here we go. You can see it's using the custom path, and this has come from that package. So whether the deployment works or not is probably not relevant here. What we're really interested in is whether the Helm itself could, okay, it did work, but whether Helm itself could be called, and it could in this case. So that's another way around this. The issues with having either Helm version 2 or Helm version 3, or no Helm at all available on the particular worker that you're trying to deploy with. So The takeaway, I guess, for supporting Helm here is that for the feeds, if in doubt, always use the complete feed URL, which is one that includes index.yaml. And the easy way to verify if this URL is actually valid is just stick it in a browser and see if you get an error or if it asks you to download a file. So you can see that this should go through and search that feed. Yep. So that's good. The other gotcha that people will run into is this naming convention here. It's less of an issue with the version of Octopus coming out because we have worked around the need for this package ID to exactly match the directory inside the archive. But still, this might trip people up that the default chart file names separate the package ID and version with a dash, whereas Octopus expects it to be separated by a dot. And the other thing is there has been we do tidy up a lot of the issues around Helm quite frequently. So a reasonable question to ask people is, what version of Octopus do you have, and can you upgrade to the latest version? Because that will quite often catch a lot of these particular issues as well. And that's all I really wanted to show. So did you have any questions or any specific things you wanted to dive into before we wrap up?
I can't think of any extra questions at the moment.
Okay. All right. Well, I think we'll leave it here, and I'll get the recording and make it available once it's all ready. Okay. Thanks for listening.
Yeah, thanks for that.
And I'll catch you next time.
Yeah, have a good one. See ya.
See ya.